In this video, we will talk about commutative property in binary and mathematics, right? So let's quickly look at what it means. So this is the operation, right? What is the operation? Operation is just like the way of combining things together, right? How you are going to combine two things together since you are dealing with a binary. So bi means or two. We will focus on commutative property. What is a commutative property, or what do we call, or under what circumstance do we say that these two guys are commutative? That's the most important thing. Now, if you haven't watched that video, you may consider watching how best we explain the binary operation. I'll leave the link somewhere in the descriptions. Now let's check that. We have this guy and this guy. We want to combine them together, and then let's see how we will combine them, or what is the law, right? So this guy is here, there's another guy. We want to combine it. So how do you combine them? You combine them by bringing the first person, and then you add the second person, and then you subtract that by what? The multiplication of the two. Is that okay? Arrangement matters in what? Binary operations. So pay close attention to that. So this is the law, right? This is what they are saying. For us to combine you and your friend, then you must come first, your friend will follow for the second time. Then the third part is that you subtract that from after multiplying the two of you guys together. Is that okay? So this thing here just simply means that you guys are coming from what? A real number system. We are coming from this house. The house, which house? A real number house, right? It means that you and your friend are members of a real number house. That is how simple this thing is. So let's dive into the main importance of the video by explaining the commutative property. So this is the law that we are going to use to explain that. Now, what you must know is this. Is that okay? This is one thing you have to know. If you don't know this, you can never solve a commutative, right? It's a law, right? It's just a rule that you have to obey. The rule says that for you, both of you to be commutative, you and your friend, of course, to be commutative, what you must satisfy is when I bring you first, arrangement matters over here. So when I bring you first and I combine that with your friend, you must be the same as when I bring your friend first and then bring you second. Are you getting the point? Let's say this is an arrangement. You come first before your friend. And then if we interchange you, then it means that your friend comes first before you. Then you must get the same result. That is what we mean by commutative. Is that okay? This is the law. If you know this, you can solve any commutative problems under mathematics. Now let's demonstrate that by an example. So we are going to use this is the law that we are dealing with, right? They say to combine both of you, you must obey this. Now let's check that. So this is just a pure example. We want to prove whether this is what a commutative. What do you have to do? You have to obey this, right? You have to obey this. Either you come first and your friend follows, and then your friend comes first, then you follow. Is that okay? Now let's check that. Now we know. So we start by stating the commutative property. So this is what a commutative property says, that x operation y must be equal to y operation s, right? If you interchange then you must get, this is the equality sign over here. Both of you has to be the same, irrespective of what the arrangement. So this is the arrangement that we are going to talk about. Let's pick the first part. So this is the first. We are going to check whether this guy is equal to that. Is that okay? That is how we solve a commutative problem solver. So this is the first one. So the first one, of course, we know that this is the original one being given to us. So the x plus y minus what? X y, right? So this is the original one. So it depends on the arrangement. Is that okay? Arrangement matters in what? Binary operations. So pay a close attention. So what I'm having for the first time is what? This is the equation one. So this is how it looks like. You have to go and check if you interchange. Are you going to get the same thing? Right? That is the commutative. If you interchange, are you going to get the same thing? So let's interchange and see. So this is for the first one. So let's check the first one. After we interchange it, so look at what is happening. Y comes first and then x follows, right? Your friend comes first and then you follow. So you come, your friend comes first and then plus all you, and then you subtract that by the multiplication of both of you. Is that okay? So let's check that. If you are doubting whether this is correct, this and this are the same, then you see additions and subtractions are commutative. What I mean by that is that irrespective of whatever you or how best you arrange the addition and multiplication, then the answer will be the same, right? When I say 2 plus 3, that should be 5. What will happen if I say 3 plus 5? 3 plus 2, sorry. 3 plus 2, that will also give me 5, right? So when I change this to multiplication sign, still the results are still the same. Is that okay? That is why sometimes you say that addition and multiplication sums are commutative. So don't worry, if you are not okay with this, don't worry. So I will show you a very simple trick for you to come up with that. After you arrange this and you don't know how to manipulate it to look like similar like this one, it's not always the same. Is that okay? So don't force yourself. For you to overcome that challenge, of course, this I rearrange this one to look like something like this. Is that okay? Don't force yourself in doing that. So I have x first and then plus y, because I know that additions are all commutative and then multiplications are also commutative, so I can rearrange this. Don't worry, if you can't rearrange this thing to come up with your final answer, then this is what you have to do. Of course, this will be the equation 2. So equation 1 and equation 2 are the same. Therefore, I can conclude that they are commutative. If you are finding it difficult in using, after you go to this point, the second part, all I have to do, let's go to the courtroom. So this is what I call a courtroom. Is that okay? So a courtroom, we are just going to verify whether what we've done is correct. Of course, this is not part of your solution, right? You may do this in some rough paper, should in case you are having an exam or a text, right? So just go to your courtroom or at the back of your paper, then just do something. Pick a random numbers. It's okay. Pick a random, because I'm very lazy. I don't want to work with a negative numbers. That is in my opinion. So I go for 1 and 2. Is that okay? 1 and 2. We are going to verify. What are we going to verify? We are going to verify whether when you pick the first part and the second part are the same. So let's pick the first part. Of course, that is x operation y, right? So based on my numbers, these guys are in the courtroom, right? These guys are in the courtroom. So let's verify. Let's judge them whether they are the same. Then if they are the same, it means that they don't have case. Okay. So 1 comes first and then 2 follows. Okay. So 1 comes first and then 2 follows. So let's see. Where is that law? That if 1 comes first and then 2 follows, where is that? Here we go, right? This one. Is that okay? So as you can see here, we are just going to replace them and check what we get at the end, right? So here will be what we are just replacing, right? So one comes first and then 2 plus 2 and then minus what 1 first and then multiply by 2. Of course, this plus also will give me 3, and then that will be minus 2. So the answer will be what 3. So 3 minus 2 will give me what 1 over here. Is that okay? 3 minus what 2 here will give me 1. Remember to put everything in bracket should in case we are dealing with a negative. And then let's say that is for the first case. So we are done with the first case on that day. Is that okay? And then let's check the second case. So the second case here is that this is what we are having. Is that okay? So this is what you are having, whereby the second person comes first. Is that okay? Whereby 2 comes first. Can you see that? Whereby 2 comes first. So let's check that. If 2 comes first, what is happening? So this is a law. This is what you have to use to judge them. Is that okay? You are going to judge this guy whereby the 2 comes first. So they say 2 comes first and then plus the first person minus what the 2 that comes first and then multiply by the first person, which is 1. So let's check that. So this is the situation, right? We are just replacing this in that. By the way, if you enjoyed the video so far, don't forget to subscribe to our YouTube channel or join our WhatsApp group whereby we interact with students one-on-one for better understanding. So let's check that whereby the second person comes first. So this is the law, right? This is the law. This law comes from here after the operation. Can you see? Right? So y plus x minus y. So we are just replacing, But remember, arrangement matters. So 2 comes first. That is the 2 here, and then plus what the second person, right? Which is 1 minus what the 2. Here is it minus the 2, and then multiply by what the 1 that comes second. So do your calculation. We know the addition and multiplication already. So this plus that will give me 3, and then minus 2 multiplied by 1, that should be what minus 2. Okay, so 3 minus 2, ooh, that would be 1, right? That would be 1. So here you can see that this guy and that guy are the same, right? So in this case they don't have any case in our court. Okay, here therefore we can conclude that the operation is what commutative. Is that okay? That is how simple the commutative is. So make sure that you understand that perfectly. This will help you to tackle any problems that comes your way relating to what? A commutative. So thanks for watching.